Hello, and welcome back to yet another retro channel. Today we're going to be looking at machine number 3 in our epic Commodore 64 Repair-a-thon. This machine has several socketed ICs, so hopefully we'll have a little easier time than we did with number 2, and this won't take 2 videos to complete. So, that being said, let's get busy. Okay, as with the other machines, this machine has been through its bath. It's been cleaned. It's been drying for a couple of weeks now, so it is dry. So the first step that I have to take is I need to go ahead and replace the power switch again. So, cue the montage. Okay, now that being done, I'm going to save myself the trouble that I experienced in the last machine and make sure that the power socket is nice and clean. Sprayed in Deoxit D5, and now I'm just going to insert and remove the connector several times to abrade against the sockets and clean them out. Should be good. And then I'm going to replace the port cover bracket. Alright. Port cover bracket is now restored, and it's time that we recheck our voltages. Okay, ready to check voltages. Power up. Oh, and the external power supply. Now we will check the 5-volt regulator. 4.95, perfect. The 12-volt regulator, 11.97, perfect. We will check the voltage on the CPU socket between pin 21 and pin 6. 4.89, that's perfect. Check our voltage at the user port, 4.87, great. And one final check. 9 volts AC at the user port, 10.27, that's great. All right, so our voltages are all good with all these chips removed. Okay, the next thing to do, since those chips are socketed, I'm going to bring up the ZIF board. We're going to power it on. Make sure that it works. ZIF board should work. And it does. Okay. So now we're going to test these ICs one at a time. Now, obviously, the most likely to be a failure is Mr. PLA. So we're going to grab the PLA from the board we're working on, pop it in the ZIF socket. Yeah. Lock it in and see what we get. Here goes. And this is a functional PLA, at least partially. That's interesting. I would have actually suspected that. So we're going to mark this PLA with a check. The next thing we're going to check, after putting back the original PLA, is we're going to check the CPU. So the CPU from the suspect board. Okay. Looks like we might have a bad CPU. Let's try reseating that. All right, CPU looks bad. Okay, put the original CPU back. Let's go ahead and check the kernel ROM. Pretty sure that's the one that's out here. 27, yes, okay. This is the kernel ROM from the test machine in the ZIF socket. And we get still a black screen. Interesting. Now this ZIF socket doesn't feel like it's locking down very hard, so I'm going to give that another shot. No. Interesting. So, looks like we have a bad kernel. Oof, that was a mistake. Looks like we have a bad kernel ROM. Yep. Okay, I've still got 2 chips to check. The VIC-2. Interesting. Not getting anything out of the VIC-2. Oh boy. Nope. Looks like we have a dead VIC-2 as well. Wow. Yep. Looks like we got another expensive repair on our hands. All right, here is one of the CIAs. We'll be looking in this case for the flashing cursor, which we do not get. Wow. No flashing cursor. Oh, yeah, no flashing cursor. So, wow. Dead CIA. Of the 5 chips that were socketed on that board, the only one that was good was the PLA. We all know exactly how rare that is. All right. So, goodbye to the Ziff board for now. Bring back the board under test. We can reinstall its good working PLA. And to get it running, we're going to have to dig deep in our stores. So, my one remaining VIC-2 chip. This is an R9, so a little bit more advanced than the R8 that was in there. Going to deoxide our sockets. Okay. Now, VIC-2. Nice. I forgot to deoxide the PLA socket, didn't I? Should do that. Okay, now we need, tell me I do have some 6510s. So a new CPU, well, a new used CPU. Good. A new CIA. And yeah, going to have to make myself a kernel. So I'm going to go off camera and take care of that, and we'll be back shortly. Okay, I'm back. And what I've done is I bought some of these little EEPROM adapter kits that adapt from a 2364, which is what the Commodore mass ROMs have the same pinout as the 2364 and the 2332 for the character ROM, but the basic and kernel are 2364s. And these little adapter boards allow you to use up to, I believe, a 64K 27 series EEPROM. What I've got in here is a 27C256 that I programmed using the TL866 Mini Pro EEPROM programmer. Since the kernel is only 8K, it's actually on the EEPROM 4 times just to make sure that it's wherever the C64 is looking for it. I built that adapter board. I programmed the EEPROM. I tested the EEPROM in the Ziff 64, and it does work. So this is now a good EEPROM, a good CPU, a good VIC-2 chip, a good CIA, and of course the PLA was already good. So we're ready to give this a test and see if we're still at black screen or if we have made any progress. and here goes nothing. Well, we're still at black screen. Okay, so now it's time to start checking our signals. We're going to switch to the scope, ground our scope probe, and start looking at some signals. So the first thing we need to look at is that we've still got our proper voltage, so I'm going to check the CPU at pin 6. Okay, so that's better, and we are getting 5 volts. Next will be reset. Reset is high, and let's make sure that it behaves correctly on startup. Now it goes pretty quickly, but oh, now we're getting something on the output. Black screen. When I had the probe on reset, well, that's weird. I'm wondering if that's happening too quickly. No, it seems to be right. All right. Let's check. Let's check our clock. See what we're getting there. We're getting 1.02 megahertz. That's a good clock signal. Okay. We're getting anything on ready? Yeah, ready has signal. Ready looks good. IRQ looks good. NMI, there's nothing there. AEC, that's a good signal. 1, 2, 3, 4. Yeah. 1, 2, 3, 4, 5, 6, 7 is an address line. That's looking relatively okay. 8. Address 1, address 2, address 3, address 4, address 5, 6, 7, 8, 9, 10, 11. 11 might be a little off. 12, 13, 14, and 15. The address lines look relatively okay. And then we'll jump to the data pins, which are 30 through 37. Starting with 37 is 0. 37 is data 0. That one looks a little suspect. There's little half signals in there. That's not good. Yeah, the data lines are looking a little off. 3, 4, 5, 6, and 7. Yeah, the data lines are looking a little off, like something is fighting to either push it up or pull it down. So we probably got conflict. Let's check pin 20 on the ROMs. 24, 23, 22, 21, 20. Yeah, basic is always high, but basic isn't doing anything. 20 here. On the character ROM, nothing. We don't have those both stuck down. I'm not sure which. Let's check outputs on the PLA. Pins 15, 16, and 17 are the 3 ROMs. Oh, that's interesting. Character ROM is being selected quite a lot by the PLA at the moment. But over here on the actual character ROM, 24, 23, 22, 21, 20. Yeah. Oh, it's okay. It's getting the signal. Then this one is kernel, and that seems to be being selected a lot. Again, I'm not sure which pin on the adapter is the chip enable. And basic, yeah, that's constantly high. So that's what's showing on the chip. Well, I think at the very least we have a bad character ROM. So I think we're going to have to pull that chip and replace it. That is this guy right here. Give it a little fresh solder while my desoldering station is warming back up. Also, while the desoldering station is charging back or heating back up, let's see what the dead test is doing. Since the last video, I did download the STID dead test ROM, which is a little more advanced than the original. Dead test is running. Let's see what we get out of here. Well, we may have one filter starting to go on the SID, but otherwise it sounds pretty good. And this looks like it is running correctly. So it could be that our only problem is the character ROM. Let me show you. I know I didn't have it connected. I didn't have it showing on the screen. Let's see if I can get it to show what it was showing a minute ago. Yeah, there. That's why I suspect a bad character ROM. That scrambled screen usually an indication of a bad character ROM. So we'll get that desoldered and replaced with a socket and get a replacement character ROM in there. I have to apologize, folks. I just realized I had the recording paused. So I'm not sure at this point. Yeah, I'm pretty sure at this point. What I did, what I've done off camera, let me show you. So I went ahead and desoldered the character ROM, socketed it, and put in a new character ROM, and poof, Bob's your uncle. The board came back to life. I was getting the basic screen with the flashing cursor. So I went ahead and put in the diagnostic harness, and what I'm getting back from the diagnostic harness, everything was good except for it was telling me that the keyboard and control port were not working properly, and it was indicating U1, which is this CIA right here. So where I am at this point is I have pulled the supposedly bad CIA. I haven't tested it yet in the zip board, but I've pulled it, and I am in the process of soldering in this socket, and that's when I realized that I was on pause in the recording software, and I do apologize for that. But nothing too complex happened. Nothing that required a lot of signal searching and figuring things out. Everything pretty much was self-evident from the results of the either the dead test or the full diagnostics with the harness. So I'm going to go ahead and finish resoldering the socket in, and then we'll put in a replacement CIA. Once we have that replacement CIA in, I will test this board with the full harness and see if it's working. If it is, great. And then I will go ahead. I will test this CIA, because I find it odd that the times in the diagnostics, the 2 times at the bottom of the screen were correct, and when loading when booting to basic, I was getting the flashing cursor. Now, I didn't hook a keyboard up to see if it was actually working, but I find it odd that the CIA would show as faulty and the keyboard show as faulty, in particular if the flashing cursor was there, if the times were right. So I'm going to test this in the zip machine to make sure it's truly bad before I mark it bad. But now to get back to soldering in this socket. Okay, that looks good. Grab another CIA. The biggest problem, I think, with these machined sockets is that they are very finicky about getting things aligned exactly right. So, all right, we got that in now. Let's reconnect our audio and video. And see what we get on the diagnostics. There we go. I'm going to let that run through a second time, and this time I'm going to do the audio from my monitor. The audio from the capture device it works sometimes. So that crackling you heard on the SID might have been the capture device. I want to hear it from my monitor to see if it's really a problem or not. I heard some of it in that. I'm sure you couldn't, because all you could be picking it up from would be the microphone. Let me switch this cartridge to the SID tester and see. I need a keyboard. This is the keyboard that actually goes with this machine, so. All right. SID tester. Okay, I think some of the filters and the envelopes are starting to go bad on that SID. I've been debating whether it's worth replacing it. I think in the interest of getting this machine back to 100%, I am going to replace it. First, I'm going to test the other SID now that I have the keyboard connector bent back into the right shape. So let's just pull the SID, or not SID, CIA. Let's pull the CIA that I put in here and put back the CIA that was in the board. Okay, switch back to the regular diagnostics and see what we get. Nope, we're still reporting that CIA is bad. All right. So I'm not even going to bother to put that into the ZIF board, since this board works with the replacement CIA and not with the old CIA. We're going to call that confirmation that CIA is actually bad. But what we are going to do is we're going to call it marginal, because it works to an extent. We're not going to toss it out. We're going to put it with our stack of possible spares. And then I guess the last thing to do is pull the SID and put in a socket. One arm SID and a little power. And video. And That's what's going on. Okay. Thought I was having a problem with my Easy Flash, and I've just realized what the problem is. As you saw there, when I went to do something with the Easy Flash, it didn't like that. The problem is I have a Rev-A motherboard here, so I'm not going to be able to play Donkey Kong Arcade for you, because I have that on the Easy Flash, and the Easy Flash and the Rev-A boards don't like each other. So what I can do, though, is I can load up Super Zaxxon, make sure it works. Needs a keyboard. Well, there you go. A working Commodore 64 250407 Revision A. That'll be it for this repair. Obviously, I do still have to restore the keyboard, restore the case, get it all back together to take stock what we lost in this repair. The SID we replaced, although the one we replaced is marginal, so I am actually keeping it. It's just got some filters starting to go bad. So the SID, the VIC-2, that's a big one. That was my last spare VIC-2. I do have some Kawaris that I'm hoping not to really use in this repair-a-thon. So I have ordered another VIC-2 6567 R8. The PLA was good, so that's nice. The CPU we lost, character and kernel ROMs, both CIAs. So this was a rather extensive repair job. It wasn't difficult because of all the chips that were already socketed. We got a big head start being able to put those chips directly into the ZIF machine and see if they worked. So the repair wasn't a complex one, but it was an expensive one. So hopefully the next board will be a little cheaper. It would be nice. But that's going to wrap it up for this one. I do apologize for the lost video in the middle of this. I'll try to do better in the future. In the meantime, if you liked this video, please give it a like. If you didn't, you know what to do there too. Subscribe to my channel if you haven't already, and ring the notification bell so you get notified when I'm posting a new video. And I guess that's it for today. So everybody out there, please be safe, be well, and we will talk to you next time. Thank you very much for watching. Bye.